All right, welcome to section 2.4, graphs of the sine and cosine curve functions. We are going to look at what we call periodic functions. This is where a graph will repeat itself, and that's when we call it a periodic function. All right, what happens is that you're going to have certain intervals or periods where it repeats. A heartbeat is a good example of that. So from this heartbeat to this heartbeat, that's the period length. All right, so one thing that we've seen from our unit circle, that when we're at the 0 for our radians, we're at 1, 0, 0, 1 at pi over 2, negative 1, 0, 0, negative 1, all the way around. And we know that the cosine of s, or cosine theta, is your x-coordinate, and sine of s, or sine of theta, is your y-coordinate on the unit circle. So what's happening to our graph? Well, as we go from 0 to 2 pi over 2 in quadrant 1, sines are going from 0 to 1. They're getting bigger. Where cosine, your x-coordinates, are going from 1 to 0. They're getting smaller. And then, as I go from 0, 1 to negative 1, 0, my x-coordinates are still decreasing all the way down to negative 1. But now my y's are going from 1, that's where they reach their highest, back down to 0. Quadrant 3, my y's coordinates will decrease from 0 to negative 1. But now I bottomed out for my cosine at its smallest possible value. It has to start making its way back up to 1. So we'll stop at 0. Then in quadrant 4, we'll make it all the way back to 1. And same thing with sine. We'll go from 0 to negative 1, then negative 1 back to 0. So looking at the sine function first, this is a true value based on the unit circle. So this unit circle, I'm going to say it's drawn to scale. 0 to 1, that's a value of 1 on my y-axis. There's the 0. Here's negative 1, drawn to scale with my radius matching my y values. So if we start at 0, your y-coordinate is 0. Pi over 6, it's 1/2. And you can see that those points correspond straight across. Pi over 3, I'm not going to go to pi over 4. That's kind of ugly to graph. And plus, I want my tick marks on my x-axis to count continuously. So I don't want to say, oh, well, right here in the middle, I'm going to put an extra tick mark. So I'm going to kind of skip over the pi over 4s. Pi over 3, I'll bet square root of 3 over 2. Pi over 2, I'm going to be matched up with my 1 for the y. Now as we go back here into quadrant 2, looking at these y-coordinates, at 2 pi over 3, I'm at radical 3 over 2, again, straight relationship. 5 pi over 6, we're at 1/2. And when we get to pi, my y-coordinate is back to 0. 7 pi over 6, we go to negative 1/2. At 4 pi over 3, negative square root of 3 over 2. There's that value. Get down to 3 pi over 2, we're at negative 1, straight across. 5 pi over 3, back to negative square root of 3 over 2. 11 pi over 6, we're up negative 1/2. Until we come all the way back at 2 pi, we're back to 0. So these are the values that I like to plot, especially the zeros, the 1/2s, and the 1s. I'll show you kind of a shortcut on how to graph radical 3 over 2 when we look at the next slide. Alright, so how to graph sine of x by hand. Number 1, put in the quadrant values for the first period. That's where you're at 0, 1, 0, negative 1, 0. That's what we're going to plot, those points. Quadrant, where are we at here? On the positive x-axis, positive y, negative x, negative y, back to the positive x. So 0, pi over 2, 1, pi back to 0, 3 pi over 2, 2 pi back to 0. So it's 0, 1, 0, negative 1, 0. Then you can repeat the pattern going to the left. Just follow the motion of the points. All right, now for better accuracy, we're going to plot everywhere where the y coordinate was that 1/2. And that's going to be right next to your tick marks by your x-intercepts. So I'm looking at the origin here. If I go to pi over 3 to the right and pi over 3 to the left, one tick mark away from that, that's when I'm going to be at a positive 1/2 and a negative 1/2. And I'm going to follow this flow of the curve. When I come over to this x-intercept, we're decreasing now. This tick mark to the left, pi over 3, up 1/2, pi over 3 to the right, down 1/2. This x-intercept, one tick mark to the left, negative 1/2. And I'll do that same pattern with my other x-intercepts. Now, this next point is optional. That's why I didn't put it down in the steps. But at pi over, let's see, this was pi over 6, this is pi over 3. The 60 degrees is square root of 3 over 2. If you type in your calculator, it's approximately 0.866. Well, if you take a half, and you take a fourth, and you take an eighth, and you add that all up, you get 7/8, which is like 0.875. So that's pretty close. So at this next tick mark, the one that's empty here, I'm going to take from here, I'm going to go up 3 halves, where I'm going to cut this rectangle in half to right here, because I can use this point as a reference. Now, from that green point up to 1, I'm going to take half of that. That would be 0.75. Half of that distance again. So again, half, half, half again. Move over to that tick mark. Oops, I guess I did it over here. There's my point. So let me go back over here. So up a half, up a half, up another half. There's my points. By this negative 1, down a half, down a half, down another half. There's those 2 points. Up a half, 1/2, 2 halves, 3 halves. Down a half, down half the rest of the distance, a half again. There we go. So I like to use the word half, or the value half, is because you use the half here at one tick mark, then we're just going to do 3 halves, half of the distance we have left to get to 1. And then we can just draw our curve. Put on little arrows because they go on forever. Your domain is going to be all real numbers, and your range is going to be from -1 up to +1. We'll put brackets on that. So your characteristics of the sine curve, the graph is continuous over its entire domain. The x-intercepts have the form of n pi, where n is an integer. So again, you'll see n's here and you'll see k's. N and k are very popular variables to represent an integer. So your x-intercepts were at 0 pi, 1 pi, 2 pi, 3 pi, 4 pi, or -1 pi, -2 pi, -3 pi. The period length went from 0 to 2 pi, so that's going to be 2 pi for the period length. The graph is symmetric with respect to the origin, so the function is an odd function. So that, if you remember, for all x in the domain, sine of -x gives you negative sine of x. All right, amplitude. Amplitude is half the distance from the lowest point to the highest point. So, okay, we said that's your range, from -1 up to 1. All right, that's going to be 2. Half of that is 1. So right now, in front of the sine of x, there's a 1. That's technically your a value, or your amplitude. So a times sine of x, this is how you're going to find your amplitude. So if I look at this example here, there's a 2 there. So any number in front of the a being multiplied to sine of x or to cosine of x, that's going to be your amplitude. But because it's a distance, it has to be a positive value. So in this example here, I have 2 sine of x. So that 2, make it positive, that's your amplitude. My period length is 2 pi. My domain would be all real numbers, and my range, check, check, we're multiplying 2 to every y coordinate because it's technically outside the function. So if we start looking at plotting our points, start at the origin 0, Normally at pi over 2 we go up to 1, but because the a is 2, and that says take 2 and multiply it to all my y coordinates are 1, it's now moving up to 2. Then back to 0. 0 times 2 is 0. 3 pi over 2, it used to go to negative 1, but multiplying it by 2 is now negative 2. Back to 0. So now, let's do the 1 tick marks left and right of your x-intercepts. So 1 tick mark to the right used to be up a half, but a half times 2 is now 1, so I got to go up a little higher. Over here by pi, this tick mark, up a half is now up 1, 1 tick mark to the right, down 1. This x-intercept left 1, down to negative 1. And there's my curve. Here, I would not do the half, half, and half because I got to double that value. So that was normally just below the 1. If I double it, okay, it's a little bit higher. I don't really need it on this one. So that forces my range to now be negative 2, comma 2 again with brackets. Looking at b, y equals negative 3 sine of x. Okay, negative 3, that's my a value, but the amplitude is the absolute value of negative 3, that's 3. I want to remember that it was negative 3 because I'm going to multiply that to all my y coordinates like I multiplied by the 2. Period is still 2 pi, domain is still all real numbers. Range, well, we saw that if we multiplied by 2 to my negative 1 and 1, I'm going to multiply 3 to my negative 1, 1. So there's my range. Bracket negative 3, comma 3, bracket. So starting at my origin, pi over 2, I usually go to 1, but now multiplying by negative 3 is going to move me down to negative 3. At pi, we're back to 0. 3 pi over 2, we usually go down to negative 1, but multiplying that by negative 3 now makes it a positive 3. And then at 2 pi, we're back to 0. Okay, x-intercept, 1 tick mark to the right. Now, 1/2 is where I usually go down or go up, but multiplied by negative 3 is now negative 3/2. So to the left of that x-intercept, down negative 3/2. 1 tick mark to the right, up 3/2. This x-intercept to the left, 1 tick mark, up 3/2. And there's my sine curve. So we can say that the range is going to be bracket negative a, comma a. We'll always put the negative to the left and the positive always to the right. Now, your period length, this is when now something is multiplied to x on the inside. This is the length of one cycle. The formula for sine and cosine is capital P for the period length equals 2 pi, that's the length of your period, but now we divide by b. Remember, transformation rules, opposite effect of what's going on. So when you see a multiplication of b to your x, we got to divide by that b. This will cause a horizontal stretch or shrink. So looking at my example, we have we're going to graph y equals sine of 2x. So b is 2. We put it in our formula, 2 pi over 2. 2's cancel. My period length is now pi. My amplitude, there's a 1 in front of the sine. Like just said, the period length is pi. My domain is negative infinity to infinity, and my range negative 1 to 1 with brackets. So how do we graph this from 0 to 2 pi? Start normally at 0. Now, to think of what we're doing here, now pi over 2 used to be at 1. But now I cut the distance in half. So if I'm here at pi over 2, 1, I have to go half the distance back. So I plot all my points like I normally do. And now I got to cut every distance in half back to the origin. So pi over 2, I'm going to cut this in half to pi over 4. Pi is going to get cut back to pi over 2. 3 pi over 2 is going to be changed to 3 pi over 4. 2 pi is going to come back to pi. All right? Now, another way of looking at, because that, well, if I plotted all my points, again, let me go back. I make all my points, then I got to slide them over, then I have to erase all those. So here's a smarter way of doing this. Okay, since I know I start at the origin and my period length is pi, go to pi with my next x-intercept. Then you know that in between these two x-intercepts is another x-intercept halfway in between. Then half of the lower half between these x-intercepts, I have to be up at 1. And half of the upper half, right there, I have to be down at -1. And so now, using this, saying, okay, now I got to go one tick mark is too far. I got to cut that in half, so I'm like half of this square here. I will be up at a half. At this x-intercept, half the tick mark to the left, up a half a tick mark to the right, down a half a tick mark to the left, down a half. And there's my curve. Now we're supposed to go from 0 to 2 pi, so we need to go fill this in. We just follow or copy this graph over. There's my half, there's my 1, there's my y equals a half, my y is 0, a half for my y, -1, excuse me, I should say -1/2, -1, -1/2, back to 0. There's my curve. So since they said from 0 to 2 pi, that's what we have to do. If the direction said fill in the entire graph, okay, we just follow the pattern over here. We just fill it all in. All right, next example, part B, y equals 1/2 sine of 1/2 x. All right, now b is a half. I put that into my formula, 2 pi divided by a half. Well, we don't divide by half, we multiply by its reciprocal. 2 pi times 2 is 4 pi. My amplitude is going to be a positive 1/2. We just found the period length. The domain, still all real numbers, but now my range altered by the a value, -1/2, 1/2 with brackets. So start at the origin. We could plot all our points. We could say, well, then normally at pi over 2, we're up to 1, but multiplied to a half. And then normally at pi, we're back to 0. 3 pi over 2 are at -1, multiplied by a half, we're at -1/2. 0 at 2 pi. And then, well, wait a minute, that's one period length to 2 pi, but it has to be stretched. So I stretch it all the way out. Again, not one of the techniques I want to do, because then I got to come in here and erase all those old points. So again, scratch that, erase. Here's what I would do. Again, start at the origin. The period length is 4 pi. I go all the way to 4 pi. That's my ending x-intercept. Now, between 0 and 4 pi is 2 pi. That's my other x-intercept. Okay, lower half. 0 to 2 pi, I'm at pi. I should go up to a 1, but again, 1 times a half is a half. Upper half, cut it in half, I'm at 3 pi. Down to not down to -1, I have to multiply that half, -1/2. Now, because this has stretched horizontally, basically doubled, then from your x-intercept, instead of 1 tick mark, we're going to go 2. Up, not up a half times a half is a fourth. From this x-intercept, 2 tick marks, up a fourth. 2 tick marks to the right, down a fourth. 2 tick marks to the left, down a fourth. And there's my curve. And that takes care of my sine function. Next video, we'll look at the cosine function.